All right. We talked about line coding. Now we're going to talk about coding that allows for error detection and error correction. So let's try to invent a way to do error detection. Let's imagine we are at the receiving end and we get some digital data. There it is. Did an error occur? Who knows? So my initial thought of how do we tell if an error occurs, we could ask them to send it again. So they might send it again. Okay, so it looks like this bit here was different the second time. So I detected an error. Which one is right? Well, I don't know. It could be 1, it could be 0. Maybe what I could do is ask for the information again. Okay, now I look and I see, well, it looks like the second and third time it was 0. So chances are it's 0. So we'll do some error correction and change that to 0. So what I just described works. The name for it is a repetition code. But it's obviously really inefficient to send everything twice just to do error detection, and to send things 3 times, that's really slowing things down. So luckily, there have been a lot of people who have worked on this problem to come up with more efficient ways. So the simplest, least costly method to do error detection is to add a parity bit to a group of data bits. The idea with the parity bit is if you have this digital information, let's imagine you add a parity bit at the end. The parity bit is going to look at the number of ones that you have, and we'll set it to make the number of ones either even or odd. So you would decide if you're doing odd parity or even parity. So in this case, if we wanted even parity, that parity bit should be 0 because we have an even number of ones. So we'll set that 0 so it's still an even number. If we were doing odd parity, on the other hand, that should be a 1 to have an odd number of ones. So the parity bit at the receiving end, if I know we're doing even parity and we receive this, I check, yep, we have an even number of ones, things look good, probably no errors occurred. Now, that would only be true if errors are unlikely. In other words, if 2 errors could occur in this short group of data bits, then we're going to miss them. So if it detects 1 error, but it won't detect 2 errors, it will detect 3 errors, but not 4 errors, and so on. So that parity bit is fine. It's good for error detection, but it doesn't do anything for error correction. If you check the parity and it's wrong, you have no way of determining which of the bits had the error.